Okay, so this is where we're picking up from on days 12 through 13, okay? And I'm just going to call this part 2, because like I said, we're spreading this out over 3 days. So rules of exponents, you guys, this is something that you've seen, Algebra 1, Algebra 2. You've seen it come up in this class as well. So you should know these, okay? This is not me teaching Algebra 1 again. You should know these. So what I want you to do is fill them in. See what you remember. Yeah, so pause it. Okay, so this is what you should have. First one is product property, which is in red. Anytime you're multiplying like bases, you add your exponent. So when you look at your example, you're doing 3 plus 2 to get x to the 5th, or you're doing 4 plus 3 to get 2 to the 7th. Power of a power, that came up yesterday. You multiply your product, or your exponents, a to the m times n. All this does for us, it saves us time, because if you look at x cubed squared, technically you could do this, right? And then follow your product property where you add your exponents, and you'd still get x to the 6th. Remember, back when you learned multiplication, why you learned it, it was a shortcut for addition, okay? So you're multiplying 3 times 2 in the second one, you're doing 4 times 2 to give you 8. Quotient property, you're subtracting. Whether you're going all to the numerator or going to the denominator, this is also the same as 1 over a to the n minus m, okay? So just remember that. I did move everything up top, so I did x to the 6 minus 2. I did 3 to the 6 minus 3. Negative exponents. You guys, for the most part, a lot of times it'll say make all exponents positive. So if you do have a negative exponent left, the way you make it positive is you put it to the denominator and make it positive. That's all it's doing, okay? So that's what I did here and here. So it became 1 over x squared, 1 over 4 squared. Remember what exponents mean when they're negative. That means that you are doing repeat division. So that's what happens when it's down there, okay? So when you take it from the top to the bottom, it's repeat division. It's making it smaller versus repeat or multiplication of your base. And then the last one is anything to the 0 power is 1, okay? You do need to be careful though. And when you have anything to the 0 power, don't get too excited and think, oh, everything is always 1. Yes, it is. But depending on how it's written. So if you have, let's say, negative 5 to the 0 versus negative 5 to the 0, are those both 1? The answer is no. Order of operations. You do parentheses first, so that's your negative 5. Exponents next. Negative 5 to the 0 is 1. But over here, you don't have parentheses. You have exponents, so you actually do that first. Then your negative comes back in. So please, please, please make sure you pay attention to those details. If you have a negative and you're taking it to the 0, yes, it becomes 1. But if that negative is not part of that exponent, it's not grouped together with parentheses, then you got to do that last, okay, or after you take care of the exponent. So don't forget your Algebra 1 skills. All right, we're going to look over here at questions 8 through 11, and I'm actually going to add in a few more to this, just so you know. So let's look at the worked out one. So what this says, it's the directions that use exponent properties to simplify each expression. Assume all variables are positive, okay? So first one that is worked out for us is this. Now, when you look at this, you see, oh, I have like bases, right? But you don't have like indexes. So you have to convert to the rational exponent form first, okay? So looking here, we convert them using what we did yesterday. So square root of x is x to the 1/2. Cube root of x is x to the 1/3. Now you have like bases. What do we do with our exponents? We add them. 1/2 plus 1/3 is 5/6. This would be our answer if they asked for your answer in rational exponent form. This is our answer if we're asked for it in radical form. For these, it didn't tell us either way. I would say if it started in radical, put your answer back in radical. Okay, so that would be your final answer for that. Okay, so let's look here. We have the cube root of xy to the 6th power. All right, so let's start with converting this to rational exponents. Your exponent stays there, but now we're going to divide by our index. And what does that become? A 2. So we have xy quantity squared. What does that equal? Well, what does it mean to square something? It means you multiply it by itself. What is x times x? X squared. What is y times y? Y squared. There is no way to write this in radical form anymore because your denominator is 1. You don't ever write an index of 1, okay? That's just not a thing, so please do not do that. And your answer is just this. There's no way to go back to radical form, okay? You can't write that as a radical. All right, next up, number 10, we have the square root of x all over the 4th root of x. Now we've learned our quotient rule, we subtract exponents. So to do that, you do have to put this in exponent form. So you're going to convert square root of x to x to the 1/2. You're going to do the 4th root of x to x to the 1/4. Okay? If we want positive exponents only, which that's going to be our goal for most of the time, not always, you want to make sure you're doing larger minus smaller. 1/2 is bigger than 1/4, okay? So this is going to equal x to the 1/2 minus 1/4, which leaves us with x to the 1/4. Again, if we wanted this in rational exponent form, that would be our answer. If we wanted it in radical form, that would be our answer. Okay, again, we started in radical. If we can write it back in radical, let's go ahead and do that. All right, if you need to go back through that and listen to it again, go ahead, okay? Number 11, we have a lot going on. We have 2 radicals. We have 2 sets of exponents. So my suggestion is to work from the outside in. Okay? Because again, think about order of operations. Parentheses. Where's our first set of parentheses? It's this right here. Okay? It's that whole thing taken to the 2nd power. So as we work in, now we have this index of 3. So instead of having an index of 3, we're going to write this to the 2/3 power. Okay? Technically, we could, I would say let's just keep working from the outside in, okay? So now, when you look here, you have power to a power. What do we do with power to a power? We multiply them. So that leaves us with 10/3, right? 5 times 2 is 10, 1 times 3 is 3. Now, we still need to get rid of that square root of 4. So we can write that as x to the 1/4, and then that's going to be to the 10/3 power. Again, we have power to a power. If we multiply that, we get 10 divided by 12, or 5 divided by 6. And if we wanted it in rational exponent form, that would be our answer. Let's go ahead and put it in radical form, since that's where it started. Okay? I want you to find some more space. Actually, we can just go above these problems because we're not going to do the proof there. We're going to do 2 more problems here just for some extra practice. Okay, so I will just call them questions 12 and 13, okay? All right, so for question 12, we are going to use our rules of radicals and exponents to simplify this, okay? And let me go over it in red. I didn't realize it was yellow. And 13, we have x to the 1/3 to the 4th power times the square root of x to the 5th. And why don't we leave all of our answers in rational exponent form, okay? So it'll say simplify in rational exponent form, since the other ones we did with radicals, okay? So let's look at 12. First things first, we see we have like bases, that's great. We want to combine them, but to combine them, we have to get them in rational exponent form. So in the top, let's write that as x to the 5/3 all over x to the 1/2. Okay, and we know how to combine with division is by subtracting our exponents. So this is going to become x to the 5/3 minus 1/2. And now all you need to do is just take the 5/3 and subtract the 1/2 from it, and that leaves you with x to the 7/6. Okay? And that is that. So we used converting to rational exponent form. We then did our quotient rule to come up with our answer. And then number 13, we have a few things going on. We have two separate terms being multiplied together. So let's simplify them each first, then let's do our multiplication, okay? So first here, you have power to a power. What do we do with exponents power to a power? We multiply. Then our next one, we can convert it and write it as x to the 5 over, remember if there's no index, that's a 2. Okay, so we did those two things in one step. Converted this by power to a power, converted this into rational exponent form. And then your last thing here is your product property, like bases. What do we do with our exponents? We add them. Okay, and so what you'll do here is you'll do 4 divided by 3 plus 5 divided by 2. You can get a common denominator to add them. You can also reach for your calculator, and it gives you x to the 23/6. Okay, so that is it for part 2 of our radical to rational exponent form. And then on Monday, we will finish this up with part 3 of days 12 through 13.